Hello students, today I would like to discuss about the concept of plate tectonics, and before going into detail about the concept of plate tectonics, we have to know about the earth crust interior. Actually, the interior of the earth is divided into layers based on their physical and chemical properties. The earth has an outer silica rich and solid crust, a highly viscous mantle, and a core comprising a liquid outer core that is much less viscous than the mantle, and a solid inner core. Therefore, we can say that the earth is made up of three main layers. Number 1 core, number 2 mantle, and number 3 crust. Now, the earth has two different types of crust. One is continental crust and another is oceanic crust. Earth has these two types of crust and each has different properties and therefore behave in different ways. First of all, continental crust. Continental crust form the land that we see today. Continental crust averages about 35 km thick. Under some mountain chains, crustal thickness is approximately twice that the thickness. Continental crust is less dense and therefore more buoyant than oceanic crust. And continental crust contains some of the oldest rocks of the earth. And second part is oceanic crust. As the name already suggests, this crust is below the oceans. Compared to continental crust, oceanic crust is very thin, about 6 to 11 km thin, and it is more dense than the continental crust. And therefore, when the two types of crust meet, oceanic crust will sink underneath continental crust. The rocks of the oceanic crust are very young and compared with most of the rocks of the continental crust, they are not older than 200 million years. And now, from that point of view, we conclude that the crust where we live has made up of continental crust and oceanic crust. Now, if we can go to the center of the earth, how we do know what the interior or internal structure of the earth is like? We need to use geophysical imaging techniques to model what is going on below our feet. For example, when there is an earthquake, it sends out seismic waves through the earth, and seismologists can measure the time it takes for these waves to reach seismic monitoring stations set up around the globe. Changes in the seismic velocity occur as the waves pass through different material, and measuring these changes tell seismologists how many layers there are and the thickness and also the physical properties of each layer. Other geophysical methods, for example, measuring different gravity, magnetic and electrical anomalies by air and satellite images, can also help to reconstruct the shallow crustal features. And apart from that, field work, boreholes and mines help us to know about the interior of the earth crust. And now, what is plate tectonics? The concept of plate tectonics is very much scientific, and this scientific, significant and advanced plate tectonic theory found in the decades of 1960s, and this is mainly based on the two major scientific concepts. Number 1, the continental drift, and second one is the sea floor spreading. The term plate was first used by Canadian geophysicist J. Tujo Wilson in 1965. And now we have to know what is plate. The rigid lithospheric slabs or rigid and solid crustal layers are technically called plates. Now, what about plate tectonics? The study of whole mechanism of evolution, nature and motion of plates, deformation within plates and the interactions of plate margins with each other and resultant reactions are collectively called plate tectonics. And the earth crust is divided into 7 major plates which are moved in various directions. These plate motions causes them to collide, to pull apart or scrap against each other. Each types of interaction causes a characteristic set of earth structure or tectonic features. The word tectonic actually refers to the deformation of crust as a consequences of plate interactions. And now I am going into detail about the plates. There are 7 major plates on the earth and that are moving extremely slowly but continuously. And what are the major plates? Eurasian plates, African plates, Indo-Australian plates, North American plates, South American plates, Pacific plates and Antarctic plates. These 7 are the major plates of the world. And what about the intermediate plates? Caribbean plates, Caicos plates, Nazca plates, Arabian plates, Philippines plates, etc. are the perfect example of these. And therefore we can state that there are actually 2 types of plate. Number 1, oceanic plates, and number 2, continental plates. The figure here shows the major plates of the world. And what are tectonic plates made of? Actually, the plates are made of rigid lithosphere. Lithosphere is made up of crust and upper part of the mantle. And now, what about the plate movements? Actually, the question of how tectonic plates are moved around the globe is answered by understanding the mantle convection shell. In the mantle, hot material rises towards the lithosphere like hot air rising out of an open oven, and the hot material reaches the base of the lithosphere where it cools and sinks back down through the mantle. The cool material is replaced by more hot material and so on, forming a large convection shell. This slow but incessant movement of the mantle causes the rigid tectonic plates to move around the earth's surface. And now, what happens at tectonic plate boundaries? Actually, there are 3 types of plate boundaries, each related to the movement seen along the boundary. Number 1, divergent boundaries. Actually, where the plates move away from each other is divergent boundary. Second one is convergent boundaries, where the plates move towards each other. And third one is transform boundary, where the boundaries, or particular in these boundaries, plates slide past each other. Actually, these 3 types are the most important tectonic activity related documents about the plate tectonic, and there are actually 3 types of plate movements also, that is convergent, divergent and transform movement of the plates. What about the divergent boundary? In plate tectonics, a divergent boundary is a linear feature that exists between 2 tectonic plates that are moving away from each other. These areas can form in the middle of the continents or on the ocean floor. As the plates pull apart, hot molten material can rises up this newly formed pathway to the surface and causing volcanic activity. Actually, where a divergent boundary forms on a continent, it is called a rift or continental rift. African Rift Valley is the perfect example of that continental rift, and where a divergent boundary forms under the ocean, it is called a oceanic ridge. From that point of view, we can conclude that one is continental rift or the divergent boundary along the continent, or second one is the oceanic ridge, the divergent boundary under the ocean. And this divergent boundary actually act as a spreading ridge. The oceanic ridges are actually shown in a particular map. You can see from the map that the progression of the oceanic crust getting older away from the oceanic ridge. From that point of view, we can say that actually the oceanic ridge are the younger one and the rocks away from the oceanic ridge are the older than the oceanic ridge. And Iceland is the perfect example of that continental rifting. Iceland has a divergent plate boundary running through its middle, and on the one side, that is North American plate, and another side Eurasian plate, form the island. And now I am going into detail about the convergent boundary. Actually, there are three styles of convergent plate boundaries. Number 1, continent-continent collision. Number 2, continent-oceanic collision. And number 3, ocean-ocean collision. First of all, continent-continent collision. When continental crust pushes against continental crust, both sides of the convergent boundary have the same properties. Neither side of the boundary want to sink beneath the other side, and as a result, the two plates push against each other and the crust buckles and cracks, pushing up, and high mountain ranges develop. For example, European Alps and Himalayas formed in this way, and we all know that Mount Everest is the highest altitude mountain on our planet, standing 8,848 meters high. This is mainly formed due to the continent-continent collision. And this is the figure of that continent-continent collision. This is the case of Himalaya. And second one was the continent-ocean collision. At a convergent boundary where continental crust pushes against oceanic crust, the oceanic crust, which is thinner and more dense than the continental crust, sinks below the continental crust, and this is called subduction zone. Actually, this subduction zone, sometimes known as Benioff zone, named after Hugo Benioff. Actually, in the Benioff zone, there is a sharp angle of 30 degree to 80 degree, and in most of the cases, the angle is found as 45 degree. So, Benioff zone is a particular type of subduction zone. The oceanic crust descends into the mantle at a rate of centimeter per year, and this oceanic crust is called the subducting slab. And when the subducting slab reaches a depth of around 100 km, it dehydrates and releases water into the underlying mantle wedges, and the addition of water into the mantle wedges changes the melting point of the molten material, and there actually form the new melt, which rises up into the overlying continental crust and forming volcanoes. Therefore, subduction is actually a way of recycling the oceanic crust, and eventually the subducting slab sink down into the mantle to be recycled. And it is for this reason the oceanic crust is much younger than the continental crust, which is actually not recycled. And subduction is a major part of the continent-ocean crust collision. And now the oceanic lithosphere substract underneath the continental lithosphere, and perfect example of this is the Andes. And third one is the ocean collision. When two oceanic plates converge, because they are dense, one runs over the top of the other, causing it to sink into the mantle, and a subduction zone is formed. So therefore, we can say that ocean-ocean collision also creates subduction zone, and the subducting plate is bent down into the mantle to form a deep depression in the sea floor, and that is called trench. And trenches are the deepest part of the ocean and remains largely unexplored. Actually, the Mariana Trench, which is almost 11 km depth, is the perfect example, or is the world's deepest trench formed in this manner. And third type of plate movement is transform boundary, and where the plate slide past each other, and these result faulting, and San Andreas fault is the perfect example of that. And here a map shows the major plate boundary and subductions of the world, ridges axis, divergent boundary, transform fault, subduction zone along the convergent boundary, etc. have the detail in this map.